Hey everybody, welcome back to Trigonometry. Today we have a really important section to look at. This is section 2.2, acute angles and right triangles. What makes this section so important is that this is the section where we learn about reference angles. And throughout the rest of the course, you will need a good understanding of reference angles in order for things to work easily for you. So we're going to learn what a reference angle is, and then we're going to talk about using the special angles as reference angles, so that would be our 30, 45, and 60. And then we'll talk about how to work backwards, how to figure out what angles are possible if you've been given a function value. So let's get started. Okay, first of all, what is a reference angle? Well, if you have an angle theta, and you want to talk about its reference angle, we usually write that theta prime. And that would just be the same variable with an apostrophe or a single quote. But in math, when we see that, we usually read it as prime. So the standard position angle would be theta, and the reference angle associated with it would be theta prime. And the reference angle is going to be the positive, acute angle made by the terminal side of an angle theta and the x-axis. So notice that the reference angle is formed by the terminal side of the angle theta and the x-axis. So the reference angle is always found with reference to the horizontal. So here in example 1, we are going to practice finding and calculating a couple of reference angles. So it says find the reference angle for each angle. And you know, a sketch always helps. So here in part A, our angle is 218 degrees. So let's draw ourselves a little coordinate system and then draw a 218 degree angle or something to represent it. Now 218 is bigger than 180, and so if we start here at the positive x-axis, in order to reach 218 we're going to have to go a little bit past the negative x-axis, and we'll call that our angle theta. Now the reference angle, you remember, is formed between the terminal side of the angle and the nearest x-axis. So right here is our reference angle theta prime. Okay, so our 218 degree angle is what we're calling theta, and this slice between the terminal side and the horizontal axis is theta prime, our reference angle. Now, can we calculate theta prime? And the answer is yes, because we know that from the positive x-axis to the negative x-axis is 180 degrees. Notice that's two whole quadrants, so that's a total of 180 degrees. But theta is a little bigger than that. Theta is 218. So if we want to find the measurement of this reference angle right here, what we would need to do is just subtract 218 minus 180. So I'm going to do that, and we find that our reference angle theta prime is 38 degrees. So keep in mind now that the reference angle is always going to be considered positive, so even if you did this subtraction backwards and got a negative angle, you would still consider the reference angle positive. And also, because the reference angle is formed between the terminal side and the nearest horizontal axis, it always will have to be less than 90 degrees. It will have to be acute. And now let's look at part B. So in part B we have 1,387 degrees. And you know, it was very helpful in part A to have a sketch, but this angle is so large that it's hard to know where to sketch the terminal side. So of course, if your angle is bigger than 360, you're going to want to start by finding a coterminal angle that's small enough that you know where to draw its terminal side. So I'm going to subtract 360 3 times, and that's going to get me down to 307 degrees. Every time you subtract 360, if the angle is still too big to draw, just subtract 360 again and keep going until you get something that's less than 360. And so now we can see that 307 will be a coterminal angle. So on our coordinate system, of course, we start at the positive x-axis, and if we go 90, 90, 90 degrees, that's a total of 270, and we have to go a little farther than that to reach 307. So I'm going to call this our 307 degree angle, and of course this is our theta, And then the reference angle will be the little slice between the terminal side of theta and the nearest horizontal axis. So right here is our reference angle theta prime. Now to calculate this angle, we're going to remember that a turn all the way around the coordinate system would make a 360 degree angle. We've got our 360 degrees divided into two slices. This big 307 degree slice right here, and this smaller slice here that is our reference angle. So if we want to find theta prime, we'll need to subtract 360 minus 307, and that will give us a reference angle of 53 degrees. Now, I want to point something out to you here while we can see these two different angles that are in two different quadrants. In part A, notice that our reference angle overlapped with theta. You can see theta goes all the way into the third quadrant, and theta prime is that overlapping area between the negative x-axis and the terminal side. But over here in part B, the reference angle does not overlap with our 307 degree angle. And that is going to happen because the reference angle is not determined by whether it overlaps with theta or not. The reference angle is determined between the terminal side of the angle and the nearest horizontal axis. See here, from the terminal side of the angle to the nearest horizontal axis. And I'm just pointing that out because I know sometimes students are looking for ways to make connections, and sometimes people will latch onto this and they'll say, oh, it must be the little overlapping slice. But then that would make, over here, that would make our reference angle here. See, if we thought it had to be overlapping, then this would be the reference angle. But it's not. We know that the reference angle is always between the terminal side and the nearest horizontal axis. Okay, now here we have a diagram of an angle theta in each different quadrant and the reference angle that goes with it. And we're going to see if we can figure out a little formula for finding the reference angle in each quadrant. So let's start with quadrant 1. So here we have a quadrant 1 angle, and you can see that angle is theta. And if we remember that the reference angle has to be between the terminal side of the angle and the nearest horizontal axis, then we can see that the reference angle is exactly the same as theta. So in this case, our reference angle theta prime is equal to theta. It doesn't really get any easier than that, does it? And now let's go look at quadrant 2. So if you have an angle theta in quadrant 2, then your reference angle, again, is between the terminal side of the angle and the nearest horizontal axis. So here is theta prime for a quadrant 2 angle. Now remember that the angle from the positive x-axis to the negative x-axis makes 180 degrees, or it covers two whole quadrants, so 180 degrees. And then you can see that in order to find theta prime, we would take 180 degrees and subtract theta from that, and that would give us the little leftover slice that is our reference angle. So in quadrant 2, theta prime is going to be 180 degrees minus theta. In quadrant 3, we've already done this, so you'll be familiar with it, but your standard position angle theta goes past the negative x-axis, and so theta is bigger than 180. Here's our reference angle between the terminal side of the angle and the nearest horizontal axis. So this is our reference angle theta prime. And so you can see here that in order to find this little slice, we need to know the difference between theta and 180. Of course, in this case, theta is larger than 180, so the formula for the reference angle will be theta minus 180 degrees. And then for an angle theta that's in quadrant 4, we remember that a full rotation is 360 degrees. And so to find our reference angle, which is this little slice right here, we just need to calculate 360 degrees minus theta. Now, I don't really want you to memorize these. I hope that just by looking at the diagrams, you can intuitively know how to calculate the reference angle. But if you can't, then you may have to memorize these. But as we use them, then you'll get so comfortable with them that you'll forget you even know formulas for them. and we'll just do everything by intuition. So you might be wondering, what's the big deal? Why does it matter about the reference angle? Well, here's the big deal. If two angles have the same reference angle, then the absolute value of their trig function values will be the same. And by absolute value, we mean that these two trig function values will have the same number, but possibly different signs depending on the quadrant. So one could be positive and one could be negative, but they'll have the same absolute value. And that means that if we know the trig function values for any acute angle that we'll call theta prime, like think 30, 45, and 60, then we also know the trig function values for any angle that has theta prime as a reference angle. So let me show you what I mean. I'm going to start with this coordinate system in the upper right, and I'm going to draw us a 30-degree angle. So of course that's quadrant 1, and that's why I'm starting in the upper right, because we have a quadrant 1 angle here. It just felt wrong to draw it over here on the left, you know. Now we could draw a little imaginary vertical line to close up that right triangle, and we know from memory that the sine of 30 degrees is 1 over 2. And if you remember the definition of sine, we know that this is y over r. So we can go back to our diagram and we can label y and r as 1 and 2. Okay, we already knew all of that, no big deal. But now let's come over here to our quadrant 2 coordinate system, and let's draw ourselves a 150-degree angle. So of course that's a quadrant 2 angle, and the reference angle here between the terminal side and the horizontal axis would be, you guessed it, 30 degrees, because we know that 150 plus 30 is 180. And now what we would normally do to find the trig function values for 150 is we would close up this little right triangle here, right? But I bet you never thought about the fact that 150 degrees is not actually inside that triangle. What's inside the triangle is 30 degrees. And so that makes it related to this triangle over here. In fact, if we think about the sine of 30 being 1/2 again, then when we think about this little triangle and the 30-degree angle, we know that 1/2 is going to have to be opposite over hypotenuse. So that makes this vertical side 1 and this hypotenuse side 2. And then if we think about the function definitions based on the coordinate system, we'll find out that the sine of 150 is going to be positive because 150 is a quadrant 2 angle, but it's going to be y over r, which is 1 over 2. And let's do the same thing for a quadrant 3 angle. So let's draw ourselves a 210-degree angle. Of course, that's in quadrant 3. The little slice here between the terminal side and the x-axis is our reference angle. And so our reference angle, again, is 210 minus 180. That's 30. And we can close up our little right triangle here. Now we know that the sine of 30 is 1/2. And so that's going to make opposite over hypotenuse be 1 over 2. And now when we think about the sine of 210, we know that the sine function is negative in the third quadrant, so I'll go ahead and put down my negative. But we also know that the sine function is y over r, so again that's going to be 1 over 2. So I hope it's starting to click for you that the function values for the reference angle are actually determining the function values for the standard position angle because the sides of this triangle are set. And the only thing that can change will be whether that function value is positive or negative, and that's determined by ASTC. So just to round things out, let's draw ourselves a quadrant 4 angle. So I'm going to draw a 330-degree angle. We know that 360 minus 330 would leave 30 degrees for the reference angle. And so when we think about that little right triangle there, and we know that the sine of 30 is 1/2, we know that these two sides will have to be 1 and 2. And so now when we think about the sine of 330, it's going to be negative because sine function values are negative in the fourth quadrant, and then it's going to be 1 over 2 because we know the definition of sine is y over r. So the sine of 330 degrees is negative 1/2. And now you can see that just from memorizing this one sine value, we memorized the fact that sine of 30 degrees is 1/2. But then by using reference angles, we're able to take that one sine value and expand it into 4 sine values total because there's one angle in each quadrant that has 30 as a reference angle. So we memorized 1, but with reference angles we expanded it into 4. So this makes reference angles a very powerful tool. We memorized the sine, cosine, and tangent values for 30, 45, and 60, and that was only 9 exact values. But now, with reference angles, we actually know the sine, cosine, and tangent for 3 angles in every quadrant, so that's a total of 36 exact function values that we know without doing any extra memorizing. And then, if you throw in the reciprocal functions, the cosecant, the secant, and the cotangent, we actually have 72 exact function values that we know by memory, all because we learned these 9 exact values in section 2.1. So let's practice with this idea a little bit. So here in example 2, it says find the values of the 6 trigonometric functions for 210 degrees. So of course we want to draw ourselves a 210 degree angle, and we know that's a quadrant 3 angle. And then we want to find the reference angle. So that's going to be the little slice between the terminal side and the horizontal axis. Of course, we've gone 30 degrees past the 180 degree mark right here, and so our reference angle is 30 degrees. So in order to come up with the function values for 210 degrees, we're just going to think about our function values that we know for 30 degrees, because 30 degrees is the reference angle. So now let's start with the sine of 210 degrees. So 210 degrees is a third quadrant angle, so we know that the sine function will be negative in the third quadrant. And then for the number part of it, we just need to think about the sine of 30 degrees, which we know is 1/2. So the sine of 210 degrees is negative 1/2. For the cosine of 210 degrees, again, we remember that cosine is negative in the third quadrant, so let's put our negative down. And we know the cosine of 30 is square root of 3 over 2. So the cosine of 210 is going to be negative square root of 3 over 2. And then for the tangent of 210, we know that the tangent function is positive in quadrant 3, so we will not write a sign here. And then we think about the tangent value for 30, and that would be square root of 3 over 3. So the tangent of 210 degrees is going to be square root of 3 over 3. And now let's get the other 3 functions. So if the sine of 210 is negative 1/2, the cosecant of 210 is negative 2, just a reciprocal. If the cosine of 210 degrees is negative square root of 3 over 2, then the secant of 210 degrees is negative 2 square root of 3 over 3. And for the cotangent of 210 degrees, we know that's the reciprocal of the tangent, but we would want to remember that this tangent value has been rationalized. Before it was rationalized, it looked like this, 1 over square root of 3. So when we flip this value over to get the reciprocal of the tangent, we see the cotangent of 210 degrees is just square root of 3. Here's example 3. Let's do the same thing for 315 degrees. So we're going to draw ourselves a 315 degree angle. That will be a quadrant 4 angle. And from that we can see that the reference angle will have to be 45, because 360 minus 315 is 45 degrees. Now because the reference angle is 45 degrees, we are going to think about the function values for 45 degrees to come up with these answers for 315 degrees. So let's determine for each one positive or negative first, and then the value. So for the sine of 315 degrees, we know that 315 is a quadrant 4 angle, and we know sine values are negative in quadrant 4. So we'll put our negative down, and then the sine of 45 degrees is square root of 2 over 2. So the sine of 315 degrees is negative square root of 2 over 2. And then the cosine of 315 degrees, well, cosine is positive in quadrant 4, so we don't need to write anything for the sine, but the cosine of 45 is square root of 2 over 2. And so the cosine of 315 degrees is square root of 2 over 2. And then for the tangent of 315 degrees, we remember that tangent is negative in quadrant 4, so put down your negative, and we know the tangent of 45 degrees is 1. So the tangent of 315 degrees is negative 1. For the other three functions, we just need to do reciprocals of the first three. And so we want to remember that this rationalized value here used to be -1 over square root of 2 before we rationalized it. So now that we have that, we'll flip this value instead of this rationalized one. So the cosecant of 315 degrees is the reciprocal of the sine value, and so the cosecant is going to be negative square root of 2. The secant of 315 is the reciprocal of the cosine value, and so that's going to be positive square root of 2. And then the cotangent of 315 degrees is going to be the reciprocal of the tangent value, and so we know that -1 is its own reciprocal. So if you flip this over, it would be 1 over -1, which would still be -1. And then this is so important that I want to do one more of these with you. So example 4 is very similar. And if you would like to pause the video and do this one on your own, then I fully encourage you to do that. And now I'm going to go through it with you. So it says find the 6 trigonometric function values for 120 degrees. Of course, we draw ourselves a 120 degree angle, and then we can see that the reference angle will have to be 60 degrees. And so to come up with the function values for 120, we want to think about the function values we have memorized for 60 degrees. Okay, so let's start with the sine of 120 degrees. So 120 is a quadrant 2 angle, and sine values are positive in quadrant 2. So the sine of 120 will be positive, and then the sine of 60 degrees we know is square root of 3 over 2. So the sine of 120 degrees is square root of 3 over 2. For the cosine of 120, we know that cosine values are negative in quadrant 2, and we know that the cosine of 60 is 1/2. So the cosine of 120 is -1/2. For the tangent of 120, we know that tangent values are negative in quadrant 2, so put your negative sign down. And then the tangent of 60 is square root of 3, so the tangent of 120 degrees is negative square root of 3. For the other three functions, we'll rely on reciprocals. So the cosecant of 120 is 2 square root of 3 over 3. The secant of 120 degrees is -2. And the cotangent of 120 degrees is -1 over square root of 3, which we will rationalize to negative square root of 3 over 3. Now, there's a lot going on here. We're using ASTC, we're using our non-memorized values from section 2.1, and we're also using our reciprocal identities and doing some rationalizing as we have to. So if you are weak on any one of those points, then putting it all together is going to feel really difficult. So if you're having trouble at this point, then figure out which one of those earlier skills is giving you trouble and go drill on that thing until it gets easier for you, and then come back and put it all together and things will go better. Now, the examples that we've done so far have all had angles that are between 0 and 360 degrees. But it's very possible that you could be asked to find a function value for an angle that's larger than 360 degrees or less than 0 degrees. So, if that happens, if your angle is larger than 360 or less than 0, you can just add or subtract 360 degrees as many times as you need to find an angle that is easily sketched. It doesn't have to be positive, but as long as you can sketch the angle and know what quadrant the terminal side should be in, you're in good shape. And then you'll do exactly what we've been doing. You'll determine the reference angle, theta prime. You'll determine the correct sign for the trig function by applying ASTC, and then you'll just find the required trig function values. That's done from memory as long as your reference angle is 30, 45, or 60 degrees, which it always will be in this section. So here is example 5, and it says find the exact value of each expression, and then it says hint, express each angle in terms of a coterminal angle. So here in part A, we're asked to find cosine of -240 degrees. Now it may very well be that you are comfortable sketching that angle in its negative state. But if you're not, then all you have to do is add 360 degrees to that to find a coterminal angle that's positive. And so if we do -240 plus 360, that's going to be 120 degrees. So the cosine of -240 degrees is equal to the cosine of 120 degrees because they're coterminal. So let's sketch ourselves a 120-degree angle and figure out the reference angle. So this slice between the terminal side and the negative x-axis would be 60 degrees, so that's our reference angle. So to know the cosine of 120, I first remember that cosine values are negative in the second quadrant, so I'm going to put down a negative sign, and then I say the cosine of 60 degrees would be 1/2. So the cosine of 120 degrees is negative 1/2. Then for part B, we're asked to find the tangent of 675 degrees. So that's too large for us to sketch it, so let's subtract 360. And then we see that the tangent of 675 degrees is equal to the tangent of 315 degrees. Now we know how to draw a 315 degree angle. We know that's going to be a quadrant 4 angle. And then 360 minus 315 degrees is going to leave 45 degrees for our reference angle. And now we're ready to find this function value. So we remember that tangent values are negative in quadrant 4, so we put down our negative sign, and then we know that the tangent of 45 is 1. So now the tangent of 315 degrees is negative 1. For part C, we have the secant of 750 degrees. Now if you subtract 360 from that, you'll have to do it twice, but you'll find out that the secant of 750 degrees is equal to the secant of 30 degrees. And of course we know 30 degrees is a quadrant 1 angle. We really don't even have to sketch it, but I did anyway. And we know that all function values are positive in quadrant 1, so this secant value will be positive. But now we need to figure out the value of it. So we memorized the sine, cosine, and tangent of 30 degrees, but we did not memorize the secant. But we know secant is the reciprocal of cosine. We know the cosine of 30 degrees was 3 over square root of 2. And so the secant of 30 degrees is going to be 2 square root of 3 over 3. And again, it's positive because everything's positive in quadrant 1. And now for part D, we have the sine of negative 405 degrees. So if we add 360 to that, then we can see that that's equal to the sine of negative 45 degrees. Now I could add 360 one more time to come up with a positive angle, but I really don't have to because I know how to sketch this angle. I just need to go clockwise 45 degrees. So from the positive x-axis, I'm going to go clockwise 45 degrees. That means this angle is in quadrant 4. And we can also see that the reference angle, which is between the terminal side and the horizontal axis, that's 45 degrees. So now we know that sine values are negative in the fourth quadrant, so I'm going to go ahead and put down my negative sign. And we know that the sine of 45 degrees is square root of 2 over 2. And so the sine of negative 405 degrees is equal to negative square root of 2 over 2. Now it takes some practice to get really good at coming up with those function values accurately every time. So drill, drill, drill. Use the Quizlet cards that I have for you in Canvas to drill this process until it comes easily to you. And if you'd rather use the Quizlet app on your phone instead of going into Canvas, then you can just search for username A10Tony and you'll be able to find all of my Quizlet decks and you'll be able to pick out the one that you want to drill. Okay, now we're going to work backwards just a little bit. You know, up till now they've given us an angle and asked us to come up with a function value. But here in example 6, they're going to give us a function value and ask us to come up with theta. So let's look at what it says. It says find all values of theta if theta is in the interval from 0 degrees to 360 degrees and the cosine of theta is negative square root of 2 over 2. So notice that we are asked to find all of the angles between 0 and 360. So we need to consider all 4 quadrants. And the first thing that I notice here is that they've given us a negative cosine value. So that negative sign is going to tell us what quadrants our theta could possibly be in. Our theta can only be in a quadrant where cosine values are negative. So if you think about ASTC, we know that cosine values are going to be negative in quadrant 2. So that's one of our thetas. And then cosine values can also be negative in quadrant 3. So here is another theta. So I've got one diagram for an angle in quadrant 2, and I've got another diagram for an angle in quadrant 3. Okay, now let's think about the number that they gave us. So we've determined that theta has to be in either quadrant 2 or quadrant 3, but now let's think about the fact that we have a square root of 2 over 2 here. So this square root of 2 over 2 is going to help us know what the reference angle is. So we recognize this number as the cosine of 45 degrees, so that tells us that our reference angles are 45. So I'm going to label this angle right here as 45 degrees. And now we can figure out what the quadrant 2 angle must be. 180 minus 45 would give us this standard position angle. So that's going to be 135 degrees. And for the quadrant 3 angle, our reference angle is right here between the terminal side and the horizontal axis. And so now we can see that the whole standard position angle is going to be 180 plus 45, so that's going to be 225 degrees. So we have two answers, and these are the only two possible, because if we went to the other two quadrants, cosine values in the other two quadrants would be positive. And so 135 and 225 are the two answers that we're going to want to put in MyLab. And I'm just going to point this out to you because people don't always realize it. But in MyLab, they will put this on the screen for you. It will say theta equals, and it'll have the braces already there, so you won't need to type the braces. And the instructions under the answer box will say something like, type your answer in degrees, separate multiple answers with commas. And so they know that whatever we're going to type in here is going to be in degrees, so there won't be any need to type the degree symbol. So all we have to do is type one angle, and then a comma, and then the other angle. And the good news is that you can type the answers in either order and it's considered correct. So when you're listing the members of a set, like you are here with these braces, then the members of the set can be in any order, and that's always true in MyLab. And here we are in example 7, and we're going to continue with that same idea of finding the angle. And so the instructions here say find all values of theta if theta is in the interval between 0 degrees and 360 degrees, and the sine of theta is square root of 3 over 2. And so we'll follow the same strategy that we did before. We will use the fact that this sine value is positive to determine our quadrant. And we know that the sine function is positive in quadrant 1. So I've got a quadrant 1 angle here, and it's also positive in quadrant 2. So I drew a quadrant 2 angle here. And now we're going to use this number to help us determine our reference angle. So which of our reference angles, 30, 45, or 60, has square root of 3 over 2 as its sine value? And that would be 60 degrees. So now we know that this reference angle is 60 degrees, and since this is quadrant 1, the angle itself is 60 degrees. And then we know that this reference angle is 60 degrees, and that means that this quadrant 2 angle is 120 degrees. And so again, when we go to type this in MyLab, we can enter the numbers in either order, but we just don't need to type the degree symbol because MyLab already understands its degrees. So let's just put 60, 120. For part B, the same instructions, but we're asked to find any angles where the secant of that angle is negative square root of 2. Now, we don't have any secant values memorized. We have sine, cosine, and tangent memorized. So the first thing we'll want to do is get a reciprocal value here. So if the secant of theta is negative square root of 2, then the cosine of theta is going to be the reciprocal of that, which would be negative 1 over square root of 2. But when you rationalize it, you get negative square root of 2 over 2. So we're looking for any angles between 0 degrees and 360 degrees that have this number as their cosine. Okay, so what two quadrants could give us negative cosine values? Well, we know that cosine is negative in quadrant 2, so let's draw a quadrant 2 angle, and it's also negative in quadrant 3. And now we need to think which of our reference angles has square root of 2 over 2 as a cosine, and that would be 45 degrees. So the reference angle here is 45 degrees, and that means that this standard position angle is 135. 180 minus 45 is 135. And the reference angle here is 45 degrees as well. And so the standard position angle is 180 plus 45, which is 225. And so in my lab, you would just type 135, comma, 225. And finally, part C. If you would like to pause the video and try this one on your own, that would be great. And now I'm going to go through it with you. So for part C, we want to find all the angles between 0 and 360 such that the cotangent of that angle is equal to square root of 3. Well, again, we didn't memorize the cotangent values, we memorized the tangent values. So let's do reciprocals for both of these. The reciprocal of cotangent is tangent, and the reciprocal of square root of 3 is 1 over square root of 3, which rationalizes to square root of 3 over 3. Now this is a positive number. So first we want to identify the quadrants where we can have a positive tangent value. And that would be quadrant 1, so let's draw a quadrant 1 angle, and quadrant 3, so let's draw a quadrant 3 angle. And then we want to recall from memory which of our reference angles has square root of 3 over 3 as its tangent value, and that would be 30 degrees. So now we know that this quadrant 1 angle is 30 degrees, and we also know that this reference angle is 30 degrees, which means that the standard position angle is 180 plus 30, or 210. And so in my lab, we would type 30, comma, 210. And that is it for section 2.2. I know that we only added a little bit of new information with the reference angles, but we're pulling together all those skills that we've been learning ever since the beginning of the course. We are using now our non-memorized values, our ASTC, our reciprocal identities. All of those things come together to allow us to do the problems in this section. And so, if you're having trouble with this section, this is a good place to get things straight. Go to your instructor, talk to your instructor. If you're in my traditional class, come to me, we'll work it out. If you are taking the class online, go to your online instructor and ask for help. Tell them what you don't understand, and they can either explain it to you or tell you where to go back in the course to find the resources that you need. But right here is like a moment of truth kind of point in the course where you need to get section 2.2 straight so that the rest of the course can go well for you. Good luck with everything. Be sure to focus on your homework, practice, 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 and Quizlet, and I'll see you guys in section 2.3.